Hi guys, welcome to this video. In this video, we are going to discuss the concept of population density. Now, as a farmer, or in all cases, population density talks about total number of particular objects, okay, within a designated area, alright? But in the case of farming or crop production, we look at population density as total number of plants or crops on a particular area or in a given area of land, alright? That's population density. Now, why do you have to determine population density? So you see that after planting, we carry out some practices we call the cultural practices. Okay. And with those cultural practices, they depend on the number of crops, a lot of factors, all right? But then the number of crops on the land also affects those cultural practices, or also determine the kind of cultural practices you should carry out on the land. For instance, irrigation. If you have a lot of plants on the farm, the probability that they might need a lot of water is high. Also, fertilizer application and other cultural practices. All right, so those are the reasons why you have to determine what you call population density. Now, the formula is given by total land area divided by planting distance. How you to derive the population density of a particular farm. Okay, so we divide the total land area by the area occupied by one plant. You see, the planting distance determines or represents the area occupied by one plant. So if, for instance, one plant is occupying 1 meter squared and the total land area is 10 meters squared, then to determine the number of plants, that will be total land area divided by number of or the area occupied by one plant. So you could determine the number of plants in the farm. That is why the formula is um, total land area divided by planting distance. That is the reason behind it. Now, planting distance equals M by N, where the M represents the inter-row distance and the N represents the intra-row distance. All right. So you have a row, you have a lot of rows, several rows on the farm, all right? So within one row, you have what's called the intra-row distance, the distance between one plant and the other, all right? On the same row. But then if you take one row and another row, the distance between those two rows, you call the inter-row, the inter-row distance. Now, we have been given an example here. For instance, planting distance for planting maize will be what? 60 centimeters by 75 centimeters, right? So in this case, if you multiply the two numbers, you're gonna get an area, all right? So 60 by 75, you get the number, and then you could see that the unit is gonna be centimeters by centimeters, which will be centimeters squared. Okay, so in the end, you're going to get something like 4,500 centimeters squared as the area occupied by one plant. So if you have the total land area, you could divide the total land area by that. Then we get the number of plants on that maize farm. All right. So that is the meaning of that. Now, we have a first question to tackle. We have to determine the number of peat plants on a 2 hectare land when the farmer plants peat at 45 centimeters by 65 centimeters. Now, that is the question. Now, from the question, you could derive something like total land area. Okay, the farmer is cropping a land area of about 2 hectares. Okay, and then the planting distance that is using to plant the wheat plant is 45 centimeters by 65 centimeters. So we could first derive the area occupied by one plant, which is always given by the planting distance. Okay, so this planting distance is in centimeters, and our total land area is in hectares. There's a relationship between hectares and meters squared, where 1 hectare equals 10,000 meters squared, right? So it means that we have to change these units, that is the units in the planting distance, to meters. So we could do everything with ease. So 45 centimeters, you're gonna convert it to meters. And to convert centimeters to meters, we understand that 1 meter equals 100 centimeters. All right? 1 meter equals 100 centimeters. So to convert 45 centimeters to meters, if 100 centimeters is 1 meter, then 45 centimeters is going to be less. If less, then we're going to divide by more. So 45 divided by 100. you're gonna get 0.45 meters. Then the same applies to 65 centimeters. You're gonna have 0.65 meters. So in meters, we have the planting distance to be 0.45 meters by 0.65 meters. Now the area then becomes 0.2925 meters squared. So that is the area occupied by one plant. I told you that's what's given by the planting distance. So to calculate the total land area, I mean the total number of plants on that peat farm, you're gonna be the total land area divided by 0.2925 meters squared. Now, I said earlier that 1 hectare equals 10,000 meters squared. So 2 hectares is gonna be what? 2 times 10,000 meters squared. You're gonna get 20,000 meters squared. So to calculate the number of peat plants, we divide 20,000 meters squared by 0.2925. So we get 68376.07. Approximately, you don't have decimal plants, so you could approximate that to whole number, you get 68376 points. So that's how you go by it. Now, let's look at the second instance. That to determine the number of plants on a hectare of tomato farm when the farmer sows 3 seeds per hole at a distance of 30 centimeters by 30 centimeters. So we are to determine the number of plants on a hectare of tomato farm. So that's the total land area. Total land area is 1 hectare. All right. So you can convert that to meters square by applying the rule that says that 1 hectare equals 10,000 meters square. Now, we tackle the planting distance, we convert everything to meters. We're gonna have 0.3 by 0.3. Is that not it? So 0.3 by 0.3 gets 0.09 meters squared. That's the planting distance or the area occupied by one plant. Now we are told that the farmer planted 3 seeds of tomato per hole. Every hole he put 3 seeds. It means you're gonna have 3 plants when after growth or after germination. You're gonna have 3 plants in every hole. So after calculating everything, we multiply our answer by 3. Okay. So is that the same formula that we were using earlier? So after dividing the total land area by the area occupied by one plant, then we multiply by 3 because this time it's not only one plant that is occupying the whole, but then 3 plants. So total land area is 1 hectare, that is 10,000 meters squared, divided by 0.09 meters squared, then times 3. So you get 333 plants. Okay, so this is how we go about population density problems. Thank you for watching the video. Subscribe if you've not subscribed to my video.